Okay, so some people I see their names, some people I recognize, some people I don't. So along the back rows, what are your names so I can get you in the roll here? Ricardo. Good. We'll make sure that you get some hours for this. What's your name?
Honeybell.
There we go. Some of them are in. I'm sorry, what was your name?
Honeybell.
Maribel. I do not see you in my list of students.
Oh my goodness.
Yeah, we're gonna figure that out.
Let me go home.
If I don't get to go home, you don't get to go home. I would be sitting there playing video games right now. I'm not gonna lie. So what was your name?
Amber.
Amber? Okay. We're only missing slightly half and less of the class. That's, you know, that's pretty good for day one. That's not good. Okay, so welcome to the class. I'm Ben, I exist. I'm incredibly awkward. I am taking anxiety medication for being in front of you guys today. Yeah, that's what I got. So you're gonna see a lot of random memes in my slideshows. I regret nothing. I saw that and I was like, oh my God, I love him. So we'll go over, before actually going over the math tonight, I'll tell you a little bit about myself, the expectations, how the class is gonna go. And I'm going to expect everybody to reach out if you need any help with anything. So, little about me. I got my associates in math at this college way too long ago. Ever since then, I've been tutoring here. When there was an academic skills center, I was lead tutor of it. After that, I kind of bounced around and ended up in the Excel program, and they needed a teacher, and here I am because they're paying me. Call me Ben. I hate Mr. It's weird. It throws me off a lot. I'm not adjusting to that well. It makes me feel weird. It makes me feel like my dad. Actually, I don't think anybody ever called him Mr. either, so I don't care. And speaking of caring, I actually do care about you guys learning. So if you have any issues with anything, have any troubles with any of the math stuff, let me know. You know, I will help you. It doesn't matter what you're doing it on. If you're on essential ed and you're just working something out, if you're, you know, if you found something online that you're running into trouble with or you're curious about, just let me know. Shoot me an email. We'll go over it. Sorry to say, you got to keep the mask on.
Oh, okay.
Yep. They're being hardcore on that right now. It got less deadly, but it's more contagious. So it's fun. At least now it probably won't kill you.
It would kill my mom.
Yeah, it could easily kill my mom. My mom is 75 with COPD. If you come in and you are sick, I will set you on fire. Yeah. So expectations. Essential education is going to be the homework for the class. It'll be monitored, so I'll be able to actually see that you guys are working with it and whatnot. Last semester, I think I had a grand total of 2 students use it. So I'm going to be watching everybody very closely this class. All of the hours on essential education count towards your hour total for the program, just as much as being in class. So if you are working on something here, you go home, you do some homework, then it's going to count for you doubly so, because you'll be able to learn a little bit more better that way. Try to show up on time in person or on Zoom. I'm not going to be waiting for any students to arrive. If you've taken this class with me before, I would be very lenient on people showing up exceptionally late sometimes. And it got to the point where I would see people strolling half an hour late on the last class. And I was like, that's not okay. So try to show up on time. It is your goals that we're working here up towards here. So, you know, it's got to happen. So send me an email if you're going to be missing class or if any issues pop up. Covered that. Yeah, so every class is going to be following roughly 1 unit from the online material on Essential Ed. So I've been essentially looking through the Essential Ed stuff, following along exactly what the lessons are, and I've taken the rough structure of Essential Education and how everything is laid out on there, and I'm translating that to the class. So roughly 1 unit every class is the way I'm going to be aiming for it. That'll get through all of the pre-HiSET stuff and some of the HiSET prep stuff. So it should be peachy. Actually not 100% on the final week of the course being review. At least one of the days in the final week is going to be review. At some point in the middle of the class, we're going to have a day where you will do a official practice test for the HiSET for math. That doesn't take horribly long. The biggest hurdle on that one is getting everybody logged in. That's the nightmare. But hey, I got to deal with that, not you.
Super stupid question. What's the difference
Difference?
between HiSET and GED?
HiSET and GED essentially get you to the same certificate. They just are done by, easiest way to look at it is different companies, different sort of ways to go about things.
Gotcha. Okay.
They're roughly the same in most respects. They structure their tests a little differently, but they cover about the same exact stuff. So
Alrighty.
I like the idea of the HiSET better because it's purely on computers and it's tons of multiple choice.
Nice.
You know, if you're really, really good at gambling, you could pass it accidentally. You're not going to, but you could. You have a very bad shot of that happening. Let's see. So class materials, bring writing utensils and something to write on. You also got that math workbook that was handed out after the orientations. That one we are going to be using somewhat sparingly. It has a very different structure. If you end up thumbing through it after this class, you'll be like, some of this we looked at and some of this we didn't. The publisher for that has a very, very different structure to it. So we're going to be borrowing from it sometimes, not always. Most of the problems I'm going to have on my slideshows are going to be very straightforward, but the ones we're going to borrow from that workbook are more like stuff you're going to see in the HiSET or the GED. They're going to be, I want to say that the HiSET and GED are 99% word problem. So I want to cover a lot of the basics on how to get to word problems on that. And you should have gotten an email from me. If you haven't, you might not have your primary email set up with Excel. So if you haven't gotten that, my email's on the slide right there. shoot me an email, let me know. I will reply back. But essentially, I'm mainly sending that out just so everybody has an easy to click link for the Zoom. And also all of these slideshows are going to be available in the Google Drive folder I have copied over there. So if you're, in class or online and you're trying to frantically write things down, don't stress it. Try to absorb the material. You can always access it later. I'm also going to be doing the in-class notes on essentially a sheet of paper over here with we're gonna say it's a modern overhead. I don't know what the current, it's a camera. It's a document camera. You're gonna be seeing most of that. I'm gonna scan it after every class and you'll be able to get all the in-class notes as well. I'm also going to forget to, oh, hey, I hit record at some point, cool. I'm also going to try to record these and put them on YouTube so you can refer to them later. I have not done that before. I am a hermit, so I don't know how to deal with the anything that relates to communicating with others. So, uploading videos, I'm gonna figure it out. Yes, I will consult you. I got Mr. Flash Drive. All my other ones have like firmware and Linux stuff. Yeah, shut up. Gotcha. Okay. What the heck was I saying? I don't even know. All right. Hey, so actual math. Who's ready to actually start this stuff? You're all excited, aren't you? Yeah. Giddy? Giddy is the word?
Always.
Yeah, you've always been kind of giddy. I missed your positivity. It's been, what, like a month and a half?
Yeah, it's been like that long.
Terrible.
Miss me?
Always. Did I? Yep, cool. Okay. So we're literally just going to start the class with the absolute basics. So if you already got the basics down, that's great. You're probably going to be able to have sleep during this one. Because I'm going to be covering a lot of the basics, multiplication, division, rounding, place value. There might be little bits that you didn't pick up on before that hopefully you pick up on tonight. You're going to find that during this course that I absolutely hate the vocabulary of math. I have no memory. The only part of my brain that seems to work is the structure part, not the one with the words. So I talk like an idiot, but I can math good. So I'll teach you guys to math good. So the main reason I say that is because this is something right here that every single time I am ever asked a question about it, I have to refer to the actual like books, because I always forget which one is which here. So essentially with the real number system, you get, there's real and there's non-real. Non-real we're not going to look at. We're going to start bouncing into imaginary numbers someday, maybe, when you're actually taking college courses and playing around with, like, I think college algebra is when you start poking at those. Math 126, top of my head. That's all I'm thinking. But until then, you're going to be dealing with the real number system. And essentially, it kind of works its way up from the basics here. Natural numbers are your regular counting numbers. 1, 2, 3, 4, 5, 6. It's all the positive kind of solid numbers. For some reason, there's a distinction with whole numbers that is exactly the same, but it starts with 0. So it's 0, 1, 2, 3, 4. Blah, 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 blah. You'll see me mostly refer to integers. That's one word that you're going to see pop up more often than any of these other structures here. In any math text or anything, that's more likely to pop up. Those are all the counting numbers you would normally think of. So it's the negatives, So -1, -2, -3, 0, 1, 2, it's every single whole number. 500 billion and one is hanging out in there somewhere. We're just not going to count out to 500 billion. And the trickiest ones are being able to distinguish between rational numbers and irrational numbers. Usually when you are dealing with questions that ask you about the real number system, that's often what they point at, is this rational or irrational? So rational literally means that any number that can be represented by a ratio. And a ratio is just a fancy word for fraction. So ratios, 1/4, 1/5, 1/2, weird, awkward fractions like 15/6. And you'll notice that decimal I have there, -2.65. Any decimal that completes, so that any decimal that finishes, like if you divided, say, 1/3. 1/3 is a rational number, but if you punched it into a calculator, you get 0.3333333, as many threes as you want. Eventually you round it off and say, okay, well, I'm stopping it at 3 at some point, right? Well, that's an irrational number at that point. If you take that 1 divided by 3 and you find that you have, actually scratch that, I'm saying something wrong. I am totally saying something wrong.
Pi.
Okay, pi is definitely an irrational number. See, I missed one particularly important part. It would also be rational if the pattern repeats. So if you punch in like a decimal or get a decimal in a calculator and it says 0.235, 235, 235, 235 forever and ever and ever, if it repeats, then it's still rational.
What if it's like a bunch of random numbers at the end and it's irrational?
Exactly.
Okay.
So the irrational numbers are non-terminating, non-repeating. Because of course I wrote the good definition right here on irrational, but I wrote a terrible one on rational. So I'm gonna have to fix that at some point. Uh-oh. There's a telephone option here. That world's just gonna blow up. Okay, so yeah, irrational numbers are non-terminating, non-repeating, and square roots that aren't perfect squares. So like, we're not going to get to square roots for a little bit, but if you add like a perfect square, like 4, because 2 squared is 4. So if you had the square root of 4, that would still be rational because you can break it down to something nice. But if you get something weird, like the square root of 3, which if I punch that into Mr. Calculator here, oh, Mr. Calculator. Yeah, I get 1.732058. Yeah, it just keeps going forever there on weird numbers. That would be irrational.
But the square root of 9 would be rational.
Yep,
It's 3.
because the square root of 9 is 3, and 3 is a rational number.
Would that make it a perfect square? Because it's a whole number?
Well, yeah,
Okay.
yeah, we'll get there, but yeah. Now, since everything is kind of this weird nested sort of structure, a better way to look at it rather than just staring at the definition is with this big ugly Venn diagram. You can see that the natural numbers is the furthest inside because it's the most basic. When you move your way out, you get to whole numbers, that adds to 0. You move your way out again, you get to integers, that adds the negative numbers. And you move your way out, that starts including things that aren't just solid numbers. You get fractions, you get terminating or repeating decimals. Get really basic decimals. 0.1, that's a rational number. Yeah. Irrational is the weird stuff. You punch it in a calculator, it's really weird. You don't see any structure to it, probably irrational. Is that a fun way to put it? I think that's a fun way to put it. It's a fun way to put it.
Will this slideshow be available to look at after class,
Yes,
like online?
yes, it is in the Google Drive folder already.
Cool.
So anybody at home could just pull out their phones. Anybody in the room could pull out your phones, click on the link in your email, click on this, and start scrolling through the rest of the class. It's entirely up to you guys. I got this. One thing I will say is that after every class, I go to the last page that we made it to and kind of trim it and kind of incorporate that into the next class. So that way I have it planned, but it'll actually be set up in the structure that the class ends up being. So, real number system examples. So I got here, state which subsets of real numbers each number corresponds to. So we're starting off with 15. Now, the easy way to look at something like this, if you have 15 and you're trying to figure out, well, which one of the groups is this going to count for? You can go back to this or the definitions and think, okay, well, what's the furthest out that 15, or that furthest in that 15 would count for, right? So 15 would count on natural numbers, right? And because of that, it will count in whole numbers, integers, and rational numbers. Because anything that can be presented as a ratio is a rational number. And you could say 15 is the same as 15 over 1, for instance. Negative 20. That one does not fit in natural numbers. It doesn't fit in whole numbers. But integers counts there, which means it would also be a rational number. Notice that anything that is a funky looking number, but still is not irrational, is going to be rational. Chances are most of these I wrote here are going to be rational. 0.
Whole number.
Yeah, doesn't count for natural numbers. Counts for whole, which means it counts for everything outside of it. Whole, integer, rational. Square root of 4. So the square root of 4, punch that into calculator if you're not familiar with square roots, you get a 2. Furthest in you can take a 2 is what? Somebody throw an answer at me.
Natural numbers.
Yes, you are correct. I mean, you're not wrong, but that's not one of the categories we're working at right now. Talking to the chat. Yes, I got the chat window open. 8/16. 8/16 can reduce a little bit. So it would actually be the same as 1/2. But even if you didn't know that, you would look at this and say, well, what's the furthest in it was going to count? It's a fraction, so it's not going to count for natural, whole, or integer.
But it is irrational because it's
It is a rational number because it's a fraction. anything that can be a ratio is a rational number. So if you see a fraction right away, all right, that's going to be a rational number. Same with this next one, 8/17. That's going to be a rational number. Wrong way there. So everything ended up being rational. We didn't have any examples of the irrational because really the only way you're going to see them at this point is funky looking square roots and weird mathematical constants. So pi is the one that's most common that you run into when you're doing like circumference or area of a circle, that sort of thing.
You do square roots of fractions.
You can absolutely square root a fraction.
I've never seen that before.
I have seen entire pages of them. Much bigger and uglier than that.
Use
Wouldn't that
with
be
triangles
technically
especially.
A rectangle of a fraction because it's not as short as a square with shapes.
Man, I don't know where your brain is going, but I don't like it.
Well, look, it's
You're making me uncomfortable.
Well, look at it. It's long, like the square root symbol is longer, so wouldn't it be technically a rectangle?
No,
Root?
no, at that point, would that be a rhombus? I mean, technically, it's not necessarily officially a shape because it's,
We're doing geometry now, or
I'm just playing.
it would technically be an angle, which we will learn later. Because that is two rays connected at a point. Yeah, that's right.
oh my God,
I'm going that way. I'm gonna break this.
that's 3 rays connected.
I mean, there's also this little one right here.
Yeah.
So there's 4. There's 4 rays there. But you know, we're mainly referring to these two. So. Okay. Hey, look, place value.
Yay.
You'd think this comes off the top of your head, but for most people, it really doesn't.
This is going to be difficult.
That's fair. We won't
Machinists
be-
don't use it like this.
Huh?
Machinists do not use it like this.
Oh, well, you're wrong. That's right. Yeah, okay. So for the most part, in this class, well, I should say this day, we're only going to be playing around with the left side. On the right side, the decimals, I think, is the next class. Could be next Tuesday. Either way, it's one of the next couple of classes. So each digit has its own place value. When you're working your way, kind of think of the decimal point as where you're like standing. Like think of that as like the baseline. So the next digit over is the ones digit because, you know, just think about money. If you got a $sign and a 9, that's how many ones you got. The next digit over is tens, hundreds, thousands, 10,000s, 100,000s, millions. They go up from there, 10 millions, 100 millions, billions, etc. But it's important to know the names of those spots because very often, especially in word problems, you'll be asked to round to the nearest something. So you might be asked to round to the nearest 1,000. You might be asked to round to the nearest 1,000th. And one thing I did want to point out, and I noticed this kind of trips up a lot of people. If you look to the right of the decimal, we don't have a ones. We have a tenths. We have a hundredths. We have a thousandths. So that's just something that can trip up some people because it's almost like you're missing one there, but you're not because I mean, think about it. If you had a dime, that is a tenth of a dollar. That's exactly what you would have, $0.10. So that would be 1/10 of that. If you had a penny, that would be 1/100th of a dollar. I don't have anything to compare thousandths and 10,000ths or millions. But it works. So speaking of rounding, that's the most likely thing we're going to be using the place values for right now. So rounding is just a means of making a number simpler, but keeping its value close to what it was. So it's adjusting the digits of a number in such a way that it gives an approximate value. It's less accurate, but it's easier to use. Like, you know, if we're talking like populations of countries, we might be starting to look at things like 1.1 million, 7.8 million, 200.23 million, stuff like that. We're not rounding off hundreds, we're literally rounding off tens of hundreds of people, like thousands and thousands of people. You're just rounding them off because, well, first of all, you have a birth rate, everything's going to change its accuracy really fast. But I mean, it's really just a means of keeping things in a structure that you would want. Like if you were rounding 9,953 to the nearest thousandth or 1,000, 10,000 is an easier number to work with, but it's a lot less accurate. You're missing, you just rounded up by 47. Things I wish I could do to my bank account. So how to round numbers? You probably got a good idea of this one. You decide which is the last digit to keep by its place value. You leave that one the same if the next digit is less than 5, or you increase it by 1 if the next digit is 5 or more. So it's essentially, do you round up or do you round down? So if you had, say, 2.35, and I told you to round up to the nearest 10th, that would be where the 3 is, right? So you'd have 2.3, but then you'd look at the next digit to see if you round up or round down. If you have 2.35, that 5 means that you're going to round up. So it would round up to 2.4. Whereas if you had 2.34, for instance, you would look at the next digit and say, oh, it's less than 5, so you're going to round down. So you always, if it says round to the nearest whatever, you look at that whatever and then look at the next digit after that and say, is it going to go up or is it going to go down? If it's 5 or more, up. If it's less than that, down. Hey, look, I have random examples here. So round to the nearest 100, 3,250. Any takers?
3,200. No.
No.
Not great.
Also,
3,000.
that'd be the nearest 1,000. We're looking for the nearest 100.
Oh.
What we got?
300.
I mean, you're missing the 3,000, but I know it was implied.
Oh, yeah, 3,300.
Yes,
That's right.
3,300, because you would look at that. Hey, look at that. Getting good on the chat. I gotta pay more attention to the chat. I am sorry. I am an awful instructor. All right.
Why can't we hear them?
Because it is typing.
Oh, they don't want to be heard, they just want to type it.
I wouldn't want to be heard.
Oh.
I'm standing here with social anxiety teaching a class. I don't know what my problem is. Yeah, but to round to the nearest 100, you look at the hundreds place, which is the 2, and you look at the digit after that. Okay, well, it's a 5, and since it's a 5, that means it rounds up. So it would go to 3,300. Now let's say we were going to round to the nearest 10, 323.5. Ideas? What was that?
320.
Exactly, 320. That 0.5 is there to throw you off. Because if I'm rounding to the nearest 10, then I don't care about anything past that next digit, right? I'm looking at that 3 in the ones place. The one at 3 is lower than 5, so it rounds down to 320. Round to the nearest 10, 499. Yeah. Yeah, it's just being nice. I don't know, I think I plagiarized 90% of things. Hey, that's what math teachers do, right? They copy off of each other's worksheets.
Don't do that with writing.
Never do that with writing. Math, everybody expects it. You know why they keep putting out new editions of books? Because it's grad students that work them out. Grad students make the problems. Grad students work them out. Half the time, they are wrong. I have disagreed with the back of the book many, many times. Sometimes it's just wrong because sometimes grad students are dumb. What's the next one? 10th? Round to the nearest 10th, 0.74. Would not be 1 because we're looking at the 10th, not the ones.
0.7.
It's 0.7. You want to be, you want to look at this as, yeah, if we were rounding to the nearest 1, then yes. That's
So you
exactly
take
what
the
it would have
4
been.
off completely, and when you turn to a 0.
Well, it turns into a 0.
What you do is you look at the 10th place, which is where that 7 is.
Right.
You look at the next digit. The
Right,
next digit is a 4.
Which is lower than 5.
Yep, so that rounds down, so it stays the 0.7.
So it wouldn't be 0.70.
Well, that's an interesting point to make, actually. The question is it going to be 0.70 or 0.7? For the purposes of this class, they are equal. You could have 0.70000, punch it in a calculator, it's just going to spit out 0.7. When would you actually use 0.70? If something is telling you round to the nearest hundredth and it has a 0 there, you would do that if you say we're working on a word problem that was talking about pennies, round to the nearest dime, 0.70 would be the way you would want to do it. So it just depends on the question.
You see where I'm coming from with that one?
Essentially, any trailing zeros at that point
You just
don't really matter. You could have 0.7 and then 10 zeros afterwards. The answer would be identical to 0.7. Who wants to round to the nearest hundredth on 3.141?
Would it be 3.100?
I see where you're going with that. That would be the
Oh,
nearest.
3.1.
It'd be 3.14 because we're looking at the hundredths,
Oh, right, okay.
which means we're looking at the second digit after that decimal. Yeah, so
Wait, so is it like going backwards?
think of it as going,
Like the.
yeah, so
the
let's go
numbers
back.
with The TH at the end?
Uh-huh.
Yep,
They're on this
Oh,
side of the
okay,
decimal,
I
yeah.
see where I'm getting confused now, okay.
yep. So
Right.
remember going back to this guy, I said that it could throw you guys off if there's a ones place here and it just jumps to tenths here. I see that starting to happen here. That happens.
So the decimal, you go this way, but with the normal number.
And
Yep.
they all have the TH at the end, the
Right,
thousandths,
right.
hundredths.
Thank you for clarifying.
If the bill at a furniture store comes to $3,257, what is the rounded value to the nearest 10? Euler. Euler. So look at the digits. Remember that 7 is standing in the ones place. The 5 is standing in the tens place. 2 is in the hundreds. 3 is in the thousands.
You're not doing anything with the hundreds place, just the tens place, right?
Yeah, so you look, I heard some right answers. Sorry, I was distracted by typing in the chat. But in this case, yeah, you're looking at the tens place, which is the 5, looking at the next digit, which is the 7, saying, okay, is that going to go up or down? Well, because it's a 7, it's higher than 5, so it goes up. So 3,260. I'm proud of you guys. The little guys are growing up. Oh my God. Not that high. Okay. And about the same question. The bill comes to 3,284. What would be the rounded value of this amount to the nearest 10? The same place value we're looking at.
3,280.
Boy, howdy. 3,280 would be your answer. Because you look at the next digit, which is a 4, it's lower than 5. So this guy goes down, 3,280.
Yeah, I think I remember doing these in, what was it, I think middle school.
Realistically, you kind of do these on and off your entire life. I mean, really, if you think back on it, how many times during school did they tell you what year they made the Magna Carta? It was a lot of those years.
Oh, what?
The Magna Carta.
I don't know what that is.
Exactly.
Oh, sorry, history nerd.
I know, but like that's the thing. You learn these things over and over and over again. Sometimes they stick, sometimes they don't. I can tell you the last name of a poo from The Simpsons, and I heard it once, and I don't know why that stuck.
I remember back in school, there was the decimals that missed me.
Cool, we're gonna do a lot of those.
Cool.
I'm gonna do extra.
I always do them all in the same direction.
We're gonna have fun with it.
I hate to be a dick, but like, dude, your math. Sorry. My mom like could actually die from Omicron. I'm super paranoid about it.
It's mostly the vaccine people dying from right now.
Leave it alone. Moving on. Hey, look, we're adding and subtracting now. We're doing math. It's time to actually do math.
Yay.
Yeah. So we're gonna do some nice and early long addition, long subtraction. That's, you know, the whole stacking things and columns and adding and what have you. So it's 2 operations which involve bringing 2 or more numbers or things together to make a new total. I added the or things because, hey, it leaves it open for algebra later. Haha. Or monkeys, if you're adding monkeys. Sometimes in these problems, people go to the store and buy 400 grapefruits. You don't know why, you don't question it. You wonder if they talked to the manager and had it delivered specially for them, because that's a lot.
Are they at Costco?
Let's say he's not at Costco. Let's say he's Rayleigh's and the manager on duty is crying. Oh
no. My partner was the produce manager at Rayleigh.
Good. So the basic structure of that is when you're adding them together, the numbers line up by place value before adding. So with decimals, everything lines up at the decimal point before adding. So we're gonna have fun with that one at some point. Subtracting is similar to adding. So you line them up by place value and subtract, borrowing from the next column when necessary. So I wrote this up and I feel like it was kind of pointless to write it up because it's so much easier to just do it than it is to talk about doing it. But I figured that if somebody went to the notes later, confused, it would be nice to have something written out. So the general way that you're doing these is by column operations. So you place your numbers on top of one another vertically by place value. Then you add the columns one at a time from the right side. When the column adds 10 or more, the tens place carries over to the next column. So subtraction works similarly, but kind of the other way around. When the top number is subtracted from the bottom would result in a negative, or another way I could have written that is if the bottom number is larger than the top number, you have to borrow a 10 from the next place value. The tricky ones are when you're subtracting a large number from a small number. And by tricky, I mean you just kind of have to remember one thing. When you're doing this type of subtraction, it only works when the top number has a larger value. So if I was saying do like 10 minus 100, you would actually say, oh, okay, well, that's a small number minus a big number. So you just say, okay, this answer is going to be negative, and you would do it kind of the other way around. You would write it as 100 minus 10. That's the only way to do that. And I always thought that was weird.
So it's negative 90?
Yeah.
So it's just 90 and then you throw a negative in front of it?
Yep, exactly. You literally just do it the other way and throw a negative at it.
That makes this seem way easier.
Yeah. And this one I actually had from the last class. The last class I didn't actually work out any of this column stuff. I was like, yeah, if you're doing the high set or the GED, they hand you a calculator. Or there's a calculator on the screen. So I kind of skipped over a lot of that. This is the foundations class. So I'm going into a lot more detail and a lot more things. But I kept this slide in because this is just, I always found this to be useful hints for everybody. So when you're adding negative and positive numbers together, I always find people kind of getting thrown off by that. Like if I told you to combine, like add negative 70 and negative 60 together, people look at me with like a deer in the headlights. And the easy way to do it, I have written here, if the signs are the same, either both positive or both negative, you can add the numbers together and keep the same sign. So if you're adding a negative 60 to a negative 70, I would say, okay, well, both of those signs are the same, so I know my answer is going to stay negative. And I just kind of stack the numbers together. 60 and 70 gives me 130. So my answer would be negative 130. But if the signs are different, one's positive and one's negative, say, I don't know why it takes me a minute to think of random numbers, negative 40 and 50. If I had negative 40 plus 50, I would say, okay, well, one's positive and one's negative, which means I'm going to keep the sign of the larger number.
Which is 50 positive.
Yeah.
So
So if I have
the
positive
50 minus 40 is 10.
Yeah.
Okay.
So you do the bigger number minus the smaller number, and you keep the sign of the larger number. And that's kind of a good way to do it if you're not wanting to, if you don't have a calculator handy and you want to do things on paper and you look at a problem and you're like, I can see the answer, or I can see how I can do it, but I'm going to get screwed up on the signs. That's one way to keep that straight. Because if there's one thing I've seen myself and everyone else do, it's screw up signs. So most of what I'm going to be going over, I am going, if I see a helpful hint on keeping things straight, I'm going to tell you, like at all times, because if anybody makes those mistakes, it's going to be me. I've never gotten 100% on a math test. I always screw something up. Heck, even happened on a calculus test once. I got really close to 100%, got like 98 point something. I pulled out an 8 instead of a 1/8. which means I gave the answer as 64 times what it should have been. Oops. Little things. So number lines, you've probably seen these at some point. Literally, they're just useful for being able to keep things straight. They're useful to be able to tell which numbers are greater or lesser. A number on the left is smaller than a number on the right. That's useful for people to know because when you start getting into weird, tiny little decimals, that's when it gets kind of fuzzy. It actually is useful to help add and subtract numbers together on the number line, which honestly I wasn't really familiar with until I was putting this together, and I was like, oh, that's kind of cool. That's kind of cool. I like it. All right. And yes, I know I'm going through a bunch of things before we get to actual problems, but you know, we're having fun. After the next round of problems, I'll probably take a break. I like to have a 10-minute break in the middle of class because you guys are sitting in a 2.5-hour math class. Nobody's happy about that. No, I'm not happy about teaching it. I've never even taken a class this long, let alone top one, Jesus. I respect you guys. I couldn't do it. I am a wuss. So we're not going to play too much with the inequality symbols here. We're just going to look at greater than, less than. When two values are equal, use the equal sign. So 2 + 2 is equal to 4. That's not patronizing you or anything. It's just saying that's the operation of 2 + 2 on the left is equal to the 4 on the right. I always like to keep that in mind, the way that works, because when we start playing with other more complicated stuff, I almost like to think of the equal sign as like a balance. That also keeps the whole what you do going.
So it's like the center of a scale for an.
Yeah, I kind of like to think of it as like a center of a scale. So if I'm screwing around with one side, I have to screw around with the other side to keep it balanced. When one value is smaller than the other, we use a less than sign, and when one value is bigger than another, we use a greater than sign. Which one's less than, which one's greater than? Think about the direction it's open. That's pretty much it. Less than the small ones on the left, greater than the small ones on the right.
I always learned that with the Pac-Mans. Waka waka.
That's one way to do it. Now I just want to play Pac-Man.
I was
Yeah.
taught like alligator, the bigger alligator is the smaller alligator.
We're just getting more and more violent with our math here.
I mean, it's math. Doesn't it make you violent?
Sometimes. It depends on how long I take to make these slideshows. Since I didn't cover most of this in the last class, I actually got, this one actually took me like 2 days to put together. On and off, I wasn't paying attention the whole time. I minimized it. I played video games.
That's always fun.
And here is a pile of problems. Pile of problems.
Okay.
So this is when we're gonna play with the document scanning thing. Actually, no light coming out of that. That thing's so dim. Let's see. Oops.
Whoa.
Oops. Oops, I'm breaking.
How many
something.
friction pens do you have with you right now? Just the one?
Give me a sec. Run out of ink.
No, I'm just wondering.
I have more than one.
Okay,
I have like 2 or 3.
well, I have 2 and then I have refills and I'm wondering if I'm overzealous. I'm paranoid.
That's called being over prepared, which is better than under prepared. Let's jump to Mr. Visualizer here. Hey, I'm not used to Mr. Visualizer here.
Make it big.
Can I move it? I was moving it earlier. I have to grab from the center of the top.
You can
That's
stretch it.
weird.
And
I don't like it.
Oh, whoa. It stretched out the whole view.
Yeah, it doesn't really, I wish it had like a,
It doesn't zoom in on the paper.
You can
When
focus
did
on
that,
it.
We've seen the table. all of a
You can
sudden.
focus on it. Like focus.
yeah, I'm just wondering if I can get like the direct. Yeah, that
Whoa.
would be I just want the direct picture that, like the entire thing of the camera is seeing.
Yeah, I think you have to pick the stretchy thing in the corner.
That thing,
Yeah.
that's just gonna full screen it.
Oh, weird. Do you
The
have to
paper's
pull
like
it
the
up?
Same size though as full screen.
Sorry, guys, figuring out the new stuff I'm playing with.
I like the one we had in the other classroom. The old school.
Yeah,
Yeah. 'cause this-
Do you have
yeah,
to
that was.
adjust it upward so that it sees more or no?
I literally just wanna force it to give me the entire picture this thing's actually picking up.
That might be it though.
It's whenever it stops playing vertically. Whatever. It's making me angry. I'm gonna smash it.
How's this gonna work?
Like that.
Oh,
That's gonna work. Gonna work. Got that shared. That's gonna work. That's working. I thought that was mounted. All right, I feel better. Let's saw that.
oh,
Yeah, it'll work. That's peachy. Move it over a little bit, because I'm a lefty and I'm just gonna keep punching this desk. It's gonna be uncomfortable. That'll do. Cool. I think I feel good about that. So, let's do. I don't like this problem. If anybody took a picture or anything of this last problem, I am changing number 1. It is no longer 84 plus 31, it is 84 plus 37.
oh, no.
I want to cover some concepts here. Failing miserably at covering these concepts. All right. So number 1. So we have 84 plus 37. Going old school on how we do these. We're going to end up adding them like that.
That's so fine.
I think there's 0.7 or 0.5, I don't know. But it shows up funky on document scanners.
0.7, I think, is where they start.
Yeah. I actually tried some 0.5s, that reminds me, and they were too thin.
So you probably got the 0.7 like I do.
Yeah. So when you're adding, subtracting, multiplying, dividing, I don't care, whatever, when you're doing operations that are structured like this, you always start from the right. So we just look at the ones place and add those guys together. 4 plus 7, that would be 11, right? And since we went over 10, we have to carry that 1. That's literally why I changed the problem. I just wanted to be able to carry something. Now that 1 is part of our addition. So we have 1, 8, and 3 that we're adding together. Now, one thing I do want to cover is if you're doing these and you see a way of adding them that makes a little more sense to you, like you might look at this and say, oh, well, 1 and 3 adds to 4. I like that more than 1 and 8 giving me 9 and then adding another number. You can do that. That's actually one of the things at the end of the slideshow tonight is the properties of addition and multiplication and all that. You can add these 3 numbers since they're all just being added or subtracted. You can add them in any direction you like. I can say I have 3 plus 1 plus 8. I can have 1 plus 8 plus 3. 8 plus 1 plus 3. It doesn't matter. It's all the same thing because all 3 of them are being added together. Order doesn't really matter in this case. Either way, 1 and 8 gives me 9 plus 3 is 12.
12.
We get 121. Yay. Happiness. One thing that's weird about these new cameras that I picked up on there during the orientations, check this out.
Whoa, you're upside down.
Well, yeah, they're inverted so that when you write, it's not mirrored.
I'm an adult. I'm also temporarily blind. I didn't expect the light that it's pointing at to be so bright. It doesn't look bright here. This does not look bright. Does it look like a light is pointing at this sheet of paper? It does not.
No. It looks normal.
Yeah. Yeah, it's got a light on. It looks like with the light off. Oh, that's a big difference. Come on.
Ah, that hurt my eyes.
That's literally the difference.
It just makes the paper look more white with it on.
All right. I kind of want to press all the other buttons on this thing, but I feel like that would be a bad idea right now.
Do it. Do it, do it, do
We
it, do
should
it.
test
Do
it
it.
out.
Do it, do it, do it.
Well, oh,
Oh,
I can see that way better now.
Okay, so it's got one, oh
Oh,
God.
does it go in more? Oh, wow, you can see the little dots on the paper. It goes more?
we're not trying to look at the
Oh, wow.
microscope view.
Let's see if we can see the molecular structure of the paper.
As you can all expect, I am easily distracted.
What about, okay, so two
Oh,
and
there's
3 are
exposure.
pretty
Exposure was that?
contrast and stuff and lighting.
Oh, wow, that's weird.
So number 2 and 3 are fairly easy because they use real numbers, like, you know, standard numbers, but like 4 is throwing me for a loop because of the 103.
Oh, we'll get there. In fact, let's run through a couple of these guys. I think I'm done playing like an idiot. What we got, 10 plus 90? Weird squeaky noise, thank you, machine. All right. So same idea. Normal conventions would have you put the larger number on top. With addition, it doesn't actually matter.
Oh, it don't?
Not technically, no. Just, it looks really, really weird if you have a 3-digit number on the bottom and a 2-digit number on top.
Yeah.
So that's usually why they do that. Because it could easily just throw people off otherwise. But it doesn't technically matter, but going with conventions, I am going to keep it with the larger number on top. Because that'll work out a little nicer for us. And this one's easy. I know everybody 10 plus 90, it's 100. But I just wanted to show you what happens if I add 0 to 0. It just puts a placeholder there essentially. So that way you can get to the 9 plus 1. I just wanted to show you what happens if you're doing these and you run into that. Sometimes the weirdest thing will throw you for a loop, especially if, because I know this is like I mean, most people are going back to school or having issues with that. If anybody beats themselves up over forgetting the basic stuff, stop it. You're gonna forget everything. One of my favorite things to do actually when I was a tutor at the Academic Skills Center was when we had new tutors who were in like a high level of calculus. And they were coming in like, oh, this is gonna be easy, I know everything. And then somebody asked them long division and they look like deers in headlights. And they wanna cry because long division sucks. We're gonna do it tonight, but long division sucks. But it's amazing what you'll forget. I haven't tutored calculus now in about 2 years. It's mostly gone. All of it's gone.
When did I get fired?
Calculus, I don't even know what that is.
It's pretty high level math. Like,
Well, Fred's in calculus and she was asking me questions the other day. So it looks like that.
yeah, it's not fun.
I had to wing that, and that technically this is actually just algebra. It's just really ugly algebra. I don't think you're using calculus for this.
That's algebra.
It's
It's an
high-end
algebra.
algebra, but yeah.
It's an ugly form of algebra that you're not gonna see.
I don't even know what's going on.
That looks like a,
I'm gonna be honest, that's like this stuff right here is one of my least favorite sections in the entirety of the calculus book. I literally had to Google it, and
Okay.
then
For a
did-
second, I thought I saw trig, but no.
Yeah, literally the only reason I kept this one in here and the reason that like I'm keeping it for a while is because this stuff is like hidden in the calculus book and this is what made it click for me. But it's straight up hidden at the bottom of one of the examples and I'm still angry about that. Like it does not explicitly tell you that's how you do it.
One,
But that's how you have to do the entire section. It is evil. It makes me angry. Whatever. So now that we've seen that, let's go back to these. These look nice.
Yeah, now after I've seen that, this looks like a read.
Yeah, this is great.
Yeah.
It could be time consuming. That's great. So with subtraction, you always have to have the larger number on top. Not just conventions on that one. If you have the larger number on the bottom, it will blow up. Now, one thing I do want to stress, because I hated that I didn't have a better way of saying it on that one slide. But I mean larger in the sense of how many digits or how big the number itself is, not taking into account the sign. What I want to say is the absolute value, but I didn't want to cover absolute value.
and just to clarify, so when you're lining them up by like place value, there's like an implicit decimal 000 that you would be lining up there, right?
Yes, so when we get to the point of playing with decimals, we end up lining everything up at the decimals.
Okay, because that's an easy way for me to remember where I'm supposed to line things up. Because
Yeah.
there's like an implicit 0.00 because it's a whole. And
Yeah, it's kind of like how rational numbers are anything that can be explicit, shown as a ratio. Every number can be written as a fraction. Every number can be written as a decimal. I could put a bunch of zeros right here and it wouldn't matter.
Okay, so but it's basically like $560 minus $42 is how
Yeah.
I'm thinking of it.
Right now, we're just playing with integers.
Yeah, I'm just trying to line it up in my head.
At this point, technically, we're just playing with whole numbers, because
Mhm.
we haven't actually played with directly negatives. But one thing I would want to say is if I wanted to start talking about playing with negatives, this problem is exactly the same as adding 560 plus -42. It is
Oh, yeah.
exactly the same.
I remember that from
Yeah,
shop math.
that confuses the heck out of a lot of people at first, but essentially addition and subtraction are on the same point in the order of operations because they're essentially the same operation. So,
How do you -2 from 0?
well, I'll get to that, man.
Oh, okay.
That's
I was trying to
exactly.
do it on. I just got stuck.
You have to borrow from the next column, I think.
Exactly, that's why I put this problem in here, because right
Borrow.
now you can't subtract the ones place,
Where
right?
do you borrow it from?
You go to the next digit over and you say,
turn that
okay,
into a 5, or I mean, yeah.
yeah,
Yeah,
so you
five.
look at this 6 and you're like, okay, we're gonna borrow 10 from it. So you kind of cross that out, that becomes a 5. And you bring a 1 into that place.
So now it's a 10 minus 2.
Exactly.
Okay,
And
I forgot you could do it.
mhm,
I was trying to figure out, so I know you could do something, I just don't know what.
Yep. And when I was learning this stuff, when I was a tiny little Ben, and I learned math, and it didn't necessarily click. I knew that I was doing this, but I like to show that what I'm doing is I'm essentially taking 560 and splitting that up into 550 plus 10. I'm basically taking 10 out of this 560 to put it on this digit. That's basically what's happening. It's okay. So we look at that place value, 10 minus 2, 8. Next digit over, this is now a 5, so 5 minus 4, 1. And over here, I got a 5 and nothing hanging out under it, so 5 minus nothing. Carry the nothing, you got a 5.
Well, I got the.
Samesies.
If for some reason you're looking at this and freaking out and not understanding, you could always put a 0 there. That works too.
Oh, yeah, huh?
Yeah.
I forgot about that.
Yeah, because
Placeholder, like.
A placeholder
kind of sort of, yeah, leading zeros also, just as an aside, kind of like how we were talking about how
0.000.
0.7 is the same as 0.7 bunch of zeros here.
Yeah,
42 is the same as just, you could have as many zeros as you would want right there.
and, okay.
As long as it's like
Yeah.
before the decimal.
Now, the difference being, this is something you could potentially see as an answer if you were asked about keeping things that accurate.
Right.
This is something you would never see as an answer because this means nothing.
Right.
You don't need that.
It's just a
Just-
placeholder for
Right.
you if you're doing
Yeah.
math. Okay.
Yeah, but that literally, I mean, I know 0 means nothing, but you know what I mean.
Well, you can only put a 0 in front of the number, right? Not in the back, because that'll change the whole number.
Yeah,
entirely.
yes.
Unless you put a decimal,
Right,
then
okay.
it means nothing. If you put a decimal 0.0. same.
Yeah, I could do this.
Okay, cool.
42 is the same as 0, 42.0, blah, blah, blah. Let's look at number 4.
This is the one that was throwing me.
What's that say?
78 minus 103.
I'll write it down anyway. Right now, I'm just sharing the document camera to our students on Zoom. So they can't see the examples over there on the side. I have it that way just so I can still see it. As useless as that's going to be for the rest of the page. So 78 minus 103 is exactly the situation I told you you have to be careful about. This is one of those ones where the larger number is a negative. So because of that,
You put the big number on the bottom.
we're gonna have a negative on our answer. You always put the bigger number on top when it comes to subtraction. So what we essentially are doing on this problem, since the larger number is negative, you just say, okay, well, our answer is going to be negative, and you still do the bigger number minus the smaller. It's kind of funky.
Oh, so we're subtract, wait,
Okay, so 78 smaller than 103.
right.
So that means that we're definitely gonna have a negative as an answer. So skip the like trying to figure out how far back on the negative line we would go and instead just subtract 78 from 103.
So is this normal subtraction or is this like net?
Yeah, it's normal subtraction. You just have to be careful when you're subtracting a larger number from a smaller number.
You have to
When you
make
do
sure
that, you just
negative
say,
at the bottom.
okay, my answer is gonna be negative. And you do the bigger one minus the smaller one in.
Okay, so how do I subtract the 8 from the 3 when there's nothing to borrow from in the tens place?
Right, that's what I was confused about. You turn a 10 into a 9,
Well, there in the tens place, there's a 0.
right, so you take the.
But he was right.
Nice, okay, cool.
He was
Okay, so
right, and I'm
it's
so
90.
proud.
I'm right?
You're right.
That's what I
Yeah.
thought, but I said, no, there's no way.
Yeah, so
Okay, that turns
since,
into a 9 and that turns into a 13.
yeah, so what
Okay,
ends up
cool.
happening here is you have 103 and kind of like,
I know more than I give myself credit
I already knew that and I met you before.
for.
You went up a level last class. Give yourself some freaking credit, dude.
Yeah, it was
Okay.
crazy. In reading, I went up too. They said they've never seen that before.
I'm very happy with you. You got this, man. Yeah,
Yes, okay, cool.
I've been doing this for over a decade. I can count on one hand how many people I would say were hopeless. You don't want to admit that as a teacher or a tutor, but sometimes you just run into it. I had one person who was in math 96 for like 2 years.
Damn.
I would have never called him hopeless. Dude really, really cared. And I respected the hell out of him for it. It was not it's definitely not his favorite subject, but he kept trying. God knows I would have given up forever ago.
Oh,
So then that would be 13 minus 8 and 9 minus 7, meaning negative 25.
cool.
Yeah, but I just want to make the comparison here for everybody watching in here that the same thing that happened up here when I borrowed, I'm basically taking a 10 out right here.
Uh-huh.
That's what has to happen here, but because this is 103, this whole thing became a 9. Now,
I'm surprised I knew that.
I kind of want to do another random example after this, adding a digit, just to show you what happens if it gets uglier. Okay, so let's do this as normal real quick. So we got 13 minus 8, 5, and then 9 minus 7, 2. So our answer is this negative 25.
Cool.
Now, what I wanted to point out is what happens if I had the random example, 78 minus 1,103.
Oh, cool.
I mean, the steps you're learning are the same. Never be freaked out by a larger number. Larger numbers
Same
just
deal.
means another step or something.
So would you turn the 10 into a
1,100.
9 and just have a 1 in front of that?
Yes, but I want to show you how that works on a problem.
Okay.
So what I wanted to show you guys is if the same thing happened right here, and I had to take this out and make this a 9 to make this 13 happen right here.
We could do that though.
Well, that's the thing. what happened to all the place values? You had ones,
Well,
ten.
that's not a one.
Now you have a 109.
Yes,
So you have to put it.
because you just took out these two digits and there's more stuff happening over there. You have to keep in mind that this digit became a zero.
Okay.
You have to do that in this case because otherwise,
For it to be proper.
well, otherwise you just kind of lost a digit.
Oh.
You need the zero as at least a placeholder plus
Yep.
part of the answer.
Yeah, you want to make sure because right now you have thousands, hundreds, tens, ones. If you suddenly chop into your hundreds place, that doesn't mean you got rid of your entire hundreds place. You still got to have something there. And the same
Oh, I
has to
see,
happen.
because you can't put the 9 in the hundreds, because you've now got a 13.
And you can't
Exactly.
slide that one
Okay,
over because
okay.
that'll make you miss 1,000.
Right.
Yep,
That's
so now that zero comes
So I'm like,
down.
Why can't you just, okay, cool.
So it'd be,
I
I
like how
wrote
you
this
give the
wrong.
reasoning on why we do things that we do.
'Cause that's
They didn't
literally
do
the
that,
only
They just
reason.
said you have to.
I always do that because that's literally the only way it sticks in my head.
Right, and it makes
Um,
it, like, makes sense and easy.
Yeah, some people have one way of teaching, some people have another. It always bothered me that anybody I got taught by was like, these are the steps, just do them. It'll make sense eventually.
Right, and it never makes sense.
Yeah,
And I could have used you in geometry my sophomore year of high school.
yeah, high school geometry is weird. There's all kinds of extra stuff you never touch again.
They wanted me to do proofs, but didn't explain why and how.
Right,
proofs-
And those aren't real proofs.
What they teach you
Yeah.
in high school, I think, was all weird anyways, that's why I dropped it.
Well, my geometry teacher also had gotten tenure and did not care, so.
I'm coming. Why is it negative or how do you know it's negative? Okay.
Good one.
Because in this case, well, in both of these cases, you're taking away a larger number from a smaller number. Think about it as money. If I have $50 and suddenly somebody just charged me 200, I'm not happy. I'm in the negatives. That's exactly what's happening here. You just got to keep in mind, hey, I'm taking away a larger number than what I got. All right, so I've been talking for an hour and 22 minutes straight. I think it's a good time for a break. Let's take, I don't know, let's take 15. 15 is a nice number. I like 15.
Nice.
So come back at 7:38. 7:38 is when I am going to start talking again. Yeah. And if you have any questions, ask me, type them in the chat. I'll still pay attention. I'm just gonna stop teaching for 15. Okay. All right, is everybody nice and refreshed and ready to keep going? Or did that just make you very aware of how late it was? Somewhere in the middle, maybe? Yeah. 50-50. Okay. Let's see here.
Oh, thank you.
To get it done, is it so naturally?
It's mine.
Beautiful.
I moved my car closer.
Okay. Take it. Oops, that's 1/2. I wrote 1/7 when I saw the 1/2 and 7 on 1. So these are a bunch of random numbers where it just says place them on a number line. All that is just getting things kind of in order from each other and showing you my lazy way of drawing the number line, because sometimes you'll be taught really slowly to kind of hash out everything, you know, there's a spot, there's a spot, there's a spot, et cetera, et cetera, et cetera. And I'll see some people do that for a while just to get everything on there. But really, all I care about,
Put it
Is-
in order.
I usually like to have the 0, but all I really care about is where things are in relation to each other or the scale of it. So like, as long as these ones are gonna throw me off a little bit.
Is that 1/2 or 1/7?
That is a 1/2.
Okay.
That is the ugliest 2. I'm going to make it uglier. And now an ugliest 2. I'd say its mother still loves it, but I believe technically I am the mother of that 2, and I do not love it. It is not love 2. All I really care about is that things are roughly in relation to each other where they should be. So like, if I look at -12 and I say, oh, well, that's the smallest thing I have, right? That's gonna be the furthest to the left. All that really matters is that I got that out right here. And that kind of establishes, like I said, the scale is important. That kind of establishes a scale. So I can know that halfway between that would be a -6, halfway between that would be a -3. And from that point, I can kind of see, okay, how far over my 5 should be, how far over my 7 should be, roughly. And that way things are relatively accurate, but unless you're sitting there with a piece of graph paper painstakingly drawing out a number line, you don't need to be 100% accurate. It's not going to be the end of the world. So that's just kind of how I like to do it. And from that, I can kind of see, oh, well, -3, -4, -5, -6. So that's about, that right there is about how big 5 is. Right? So that's about how big 5 would be over here. You can kind of see how big a 1 would be, that sort of thing. Because 1s are maybe about that wide, right? So I would have my 7 right there. I'm gonna put dots on them just so I remember which ones I actually care about and which ones I don't. I'm just graphing these points. They're placed on a number line, they're graphing. We're graphing in 1 dimension. There's a hair somewhere in my mask and it makes me want to cry.
I hate it when that happens, especially when it's a cat hair.
Yay. So I got those three, but where does the 1/2 go? Well, 1/2 is between 0 and 1. So it's gonna be that tiny little spot right there. And if I got a tiny little spot, there's nothing wrong with just saying, it's 1/2. That's quite tiny. I know some people are on their phones right now. So if something like that happens, or if you expect that to happen, it might be a good idea to kind of make your number line longer. If you have a bunch of funky looking fractions. Yeah, that's all I really, it might be a good idea to make it longer, just to be able to fit some things between points here. But does it need to necessarily be 100% accurate? Nah. We got all four of our points on there, so we're good. We're happy. It's beautiful, right? We're so happy. We're excited. So let's do something interesting. Because I had not actually played around with adding and subtracting by a number line before the other day. So this question tells us to, using the number line, subtract 6 from 8. So always zero in on where it's from. Subtract 6 from 8, which means that we're going to start from 8 and it's going to go 6 down. Now, I thought this was kind of an interesting way to do things, and it kind of helps solidify the way the number line works. So if I'm doing it this way, it does help to actually have things 1, 2, 3, 4, 5, 6, 7, 8. It does help to have things kind of hash marked out that way. It's because when we're subtracting 6 from this, that's starting here. Let's make that kind of above it. This is not something I want to have on the number line. I just want to show it to you guys. If I'm subtracting 6 from it, that means that we're going in the negative direction, right? 1, 2, 3, 4, 5, 6. That's where we end up. At 2. And I just thought that was a really interesting way to do these. Now, is it likely that you're actually going to have to do this on the HSE or the GED? Probably unlikely. There is stuff regarding the number line in our workbook. But I don't believe. Yeah, it doesn't cover this. Doesn't cover that. Let me double check. Didn't write down greater than or less than problems. Well, that's less than. Okay. Oh, yes, I did. Aha. Except I realized that I combined two pages from the slideshow now, so I need to make some changes. Aha. So the next problem, for each of these next couple of problems, I actually have it set up about the same way. Number 7 directly relates to the previous problem. And all it's saying is compare the values from number 6 with a greater than or less than symbol. And I just mean the values from the question themselves.
So
6 and 8. And we are looking for the symbol right here. So would we use a greater than or a less than symbol right here?
less than.
Less than, right? Because the smallest number is on the left. So we would use that less than symbol. 6 is less than 8. Okay. Speaking of 8, using the number line, add 5 to -3. So in this case, we're going to start at -3, and we're going to add 5 to it. And we can kind of be cheap about it. We're starting at the -3. We can go 1, 2, 3, 4, 5. Right there. That would be the number 2. That's where we'd be. Number 9 is the same question relating to this guy. We're going to compare the 5 and the -3. And do we use a greater than or a less than in between these two? Anybody? Bueller? No, nobody?
Greater than. No.
You would be correct.
Yeah.
Don't second guess that. That was a good one. I like it. Yeah, because since this one's negative, it's smaller, right? So this one is greater than this one. I am determined to cram the last 2 problems onto this sheet of paper. Is it a good idea? Probably not, but you know, whatever. Using the number line, combine the numbers -3 and -4. This is one of those problems where it'd be good to know the direction that you're going to be going before you draw your number line. That way you don't have to go too far in the other direction. And remember that one slide I showed you guys, both of these have the same sign. And if they have the same sign, the numbers are going to stack up and we're going to keep that same sign. So basically, we're going to be going further in the negative direction, which means I'm going to want my 0 kind of off to the right so I can nicely have my -3 or my -4. You might ask, hey, which one do I start with if I'm just if it just says combine? And in this case, it actually doesn't matter. You would actually end up at the same point, because remember, if you're adding 2 numbers together, you can add them in whatever direction you want to. They're still going to work out. So I'm just going to start with the -3, because that's our first one. And we're combining that with the -4, which means I'm going 4 in the left. So from here, 1, 2, 3, 4, gonna end up right there. And that is at -7. So that would be our answer. Real quick, I'm gonna cram number 11 in here. compare the values with greater than or less than, so that's -3. Yeah, now the pen starts flowing like crazy. -4. So, which of these two numbers is greater? Not even asking which symbol I want. Which of these is the larger number?
-3, because it's closer to 0, right?
Yes, that is what I was looking for. So because that -3 is closer to 0, I mean, you can kind of look at them. There's -4 on our number line right there. Anything going to the right is going to be larger. It's going to be a higher number, right? So because -3 is higher than the -4, that one is going to have a greater than symbol between them. And that's the type of question I might not expect on the high set, but I would expect, for instance, on our workbook. There's actually a problem very, very close to that, which I did not want to actually cover tonight because I'm not playing with decimals or fractions yet. So I might be coming back to this later. Cough, cough. But that's something that you'll run into, is having to compare numbers together like that. And as long as it goes further to the right on the number line, it is a higher number. Yep. Oh, I miss when this thing autofied. Hey, look, we're back to the slideshow. We love the slideshow. The slideshow loves us. So we've done a whole lot of adding, we've done a whole lot of subtracting. Let's go further. Multiplication and division. Multiplication on paper, not bad. Division on paper, kind of bad. Gonna have fun with that one. I don't think I have enough practice problems to go over that one thoroughly, but I think I might need to actually. I think I might end up doing a bunch of extra examples on that. So multiplication, division. So when multiplying numbers, the place value does not need to be lined up. In the case of decimals, the place value is disregarded until the end, at which point you count the total number of digits after the decimal. In the number you have multiplied, then insert a decimal point at that place in your answer. I literally copied this from another slideshow I made where I had already covered decimals. So you can kind of disregard that point. It'll make more sense when we actually do it. That's actually a very strange thing to see until you see it once or twice, and then you're like, oh, I get it. So when you divide numbers, you gotta move the decimal point to the right of the ones placed in the divisor. So you divide only by integers. And then the answer above the division symbol will be lined up at the decimal point. So essentially, when it comes to division, that's when we start doing long division. And the important thing to keep in mind here is we can only divide by integers. Now, that's not to say that you can't divide it, but it's your life will be a nightmare if you try to do long division with a decimal without trying to take care of it first. Long division is annoying enough already. So multiplication, the way we usually do it on paper is actually called long multiplication. That's right, all of these, I think even the last ones we did were long addition and long subtraction. The word long division, the phrase long division only sticks because that one actually does speak. So it's very similar to the addition ones. You write the larger number above the smaller number. And then you just start from the ones place, same as with the addition. But in this case, you're actually doing multiplication. You take the number in the ones place at the bottom number, and you multiply it by the numbers in the one place on the top number. You write the number at the bottom like you would with the addition stuff. And then you're going to do it by the number in the tens place. So the ones by the thing in the tens, then the ones by things in the hundreds. So you just keep going, you take that first guy in the ones on the bottom and you multiply it through on the top. After that,
So you create an addition problem.
you end up actually creating an addition problem. Yeah, it depends on how many digits you're multiplying with. But for instance, if you're multiplying by a 2-digit number, that's my third bullet point right here. If you start, when you start with the tens place of your second number on your bottom number, you place a 0 in the ones column below the product. So you basically start another line, you put a 0, and then you keep going. When that process is complete, you just add the products together. I'm gonna do this out of order. I want us to do the multiplication first and then the division as its own deal.
So 4, 5, and 6.
Yeah, we're gonna do 4, 5, and 6 first. So that's gonna make your lives a lot easier. I think that's better structure. Let's do some multiplication. I'm going to start with number 4, which I have as. Why did I pick that? Whatever. All right. These are things that I just pulled out of thin air last night. You'll notice that I use a dot for multiplication instead of a multiplication symbol. That is a force of habit I cannot break, because once you hit algebra, you start using the dot instead, because otherwise you have x's times x's. You got x's all over your page and your brain explodes and you treat a multiplication symbol as an x and everything blows up. And yeah, so I'm just gonna be rolling with this dot as a division symbol. Drink. Okay. So we structure this as 569 times 4 down here. And in this case, you always start with the bottom number, start with the ones place, which in this case, we only have a ones place. We're going to say, okay, that 4 times 9. So we're going to start just multiplying down. So 4 times 9. So we have 9, 18, 27.
36.
36, there we go. So we have a 36, but you always want one digit down here. So the 6 comes down here, and just like in addition, that 3 gets carried. Unlike addition, we don't add these two together right now. We take the 4, multiply it by the 6 first.
And then
which in
add
this
the.
case, and then you add them.
Okay.
So 4 times 6 is 24, plus 3 is 27. So the 7 comes down, but the 2 gets carried. Now 4 times 5, 20, plus another 2. 20.
So in the last one, you can bring 2 down, but only 1 down for anything else.
Well, the
But you
2
can't
that-
carry it further, right?
The 2 that came down was literally just because the 4 times the 5, the tens place had a 2 in it.
Yeah, but what I'm saying is the 2 digits that came down, it's just because it's the last.
Yeah, because it was the last one, there's,
Okay,
yeah, normally this 2 would carry to the next digit, but there's nothing there, so. Now, one thing I do want to cover, because I'll see people do these problems. And if you're just learning these types of things, you're gonna make mistakes. You're gonna make a lot of mistakes, you're gonna make them often. It is not the opposite of learning, it is part of it. You are going to fail horribly. Just keep going, kick its butt. One thing I want to cover is that I will see people do some weird operations here. And you'll get some answer down here that makes just no sense, like 205 or something. That'd be unrealistic to find your way here to on this problem, but I've seen that sort of thing happen. A good thing that you can do is kind of estimate. And that kind of comes from, like, say rounding. Rounding is useful for estimation. Like if I just blindly rounded this thing down to the nearest 100, so like 500. 4 times 500,
2,000.
2,000. So you know that since this is over 500, our answer is going to be over 2,000. So if you get like 705 or something like that, you know you're wrong. You can go back and double check it and mess up, or fix your mess up. So it's a good idea to do these types of problems and then say, hey, does my answer actually make any sense? Because that's how you learn. It keeps you from making as many mistakes. You get something and you're like, oh, 500 times 4 is 500. That doesn't compute. So you're like, okay, well, I screwed something up. Let's go back and check it and figure it out. So that's just a very useful skill to have.
And multiplication is just like 569 4 times.
Yes.
Okay.
This is effectively, multiplication is an extension of addition. It's saying that you have this thing this many times. So if I had 569 plus 569 plus 569 plus 569, this is what it would add to. Okay. Number 5. This one, we have 34 times a negative 14. Now that's one thing I don't think I covered, did I? Multiplying the signs.
I remember this. 2
You
negative
remember it.
equal positive,
Everybody else
right?
does, don't I?
And 1 negative equal negative.
One sec. So that's one thing I actually realized that I did not put in the slides is how to determine which sign you're going to get. So if the signs are the same, so you have a positive times a positive or a negative times a negative, what you end up with is going to be positive all the time. The only time you don't have that is when your signs are different. And one way I've actually been able to explain this, because mentally negative times a negative being a positive, you can accept it in a math class, but it kind of hurts your brain. Think of it almost like you're taking away a debt. Almost, you're kind of canceling out. A negative is canceling out your negative. So you're taking away, it's working out for you. So because of that, because of this stuff, you have a positive times a negative number here. Positive times a negative, we're going to end up with a negative sign. So we're just gonna keep that in mind for now. And we're gonna set it up like so. Now, just like the last problem, we're gonna start from the ones place in our second line. Yes, I know there was only a one place over here, but still, you always start from the ones place down here. 4 times 4, 16, which means that tens place, we're gonna carry up here. 4 times 3, 12, plus that 1, so that'd be 13. Since this is the end of that multiplication on that row, we can just write 13. So that means that 4 times 34 was 136. Now, the next thing you do is we're gonna end up starting another row down here. And it always bothered me that I would have teachers and they'd say, oh, just put a 0. And I'm like, okay, you're putting the 0 because you're moving up. But I never really understood that. That didn't compute for me. And the reason you do that is because what you end up doing, our first step was 34 times 4, right? Our next step is actually 34 times a 10, but we're just going to use it as a 1. Think about it. What's 10 times 5? 50. What's 10 times 102? 1020. Everything you multiply 10 by just adds a 0 at the end. So that's all you're doing by multiplying, by going over to this digit, by putting that 0 there, you're taking into account that you don't have to think about it as multiplying by 10. You could just think about it as multiplying by 1 and just having a 0 there as a placeholder. And it makes your life a lot easier. That's something that was never explained to me. Does it compute for you? I don't know, maybe, but if not,
That's actually really helpful.
yeah, that's what's happening. You're multiplying by 10. So that's why you put a 0 there. If we had to go further, you would have another row with 2 zeros, and that's because anything you'd be multiplying by 100. So the nice thing with this one is I'm just multiplying 1 times both of these. 1 times 4, 4. 1 times 3, 3.
Okay, and those are both negative numbers because it was a negative times a negative, right? Or a negative times a positive, right?
I don't want to bring that in right now.
So we're just doing that at the end.
I'm gonna do that at the end,
Okay.
yeah. I feel like that needlessly complicates things and it doesn't need to be complicated any further.
Okie dokie.
So what you do now that you've finished all your multiplication, is you add these two things together. So 6 and 0, 6, 3 and 4,
7,
7, 1 and 3, 4. Cool, 476.
but because it was a positive and a negative, it's a negative
Yep.
number, right? Okay.
So because we multiplied a positive times a negative number, our answer is going to be a negative number. That's just one of those things we have to keep in mind. Now, as a random aside, that there is absolutely no reason for me to teach you guys. I'm sure you've heard a lot about how Common Core sucks. Everybody rants and raves about how Common Core sucks for teaching math to kids
Okay, yeah.
in the context of that stuff, because I've seen so many rants online of people, "Oh, I don't like how they're teaching multiplication. It was easier in my day." Well, literally, all I want to show you is that weird box method that they do. And my hand's just gonna smudge that because I'm a lefty. Cool. All we're doing by doing this is essentially splitting up part of our multiplication we're taking the 14 times 34 and we're splitting it up as a 10 and a 4 times a 34. And then adding these pieces together. So that weird box method that you might see and you might not, that kids end up doing, and they come home and they're like, can you show me how to do this? And you're like, no. Technically,
Okay, but that's how I do it in my head.
yes. That is
Because I
something
think base 10, right?
that actually, the way they're teaching it to kids these days is actually both ways. They're showing them this and they're showing them this. Because this works on paper, but it's hard to wrap your head around. This is easy to wrap your head around, and it's hideous on paper. It's truly hideous on paper, but they're trying to get kids to think. Which is hard because they're kids. I know if I could go back in time, I would meet little Ben and kick him in the face.
Oh, poor little man.
Don't say poor little Ben, that kid is a dick.
That's on a recording.
Oh yeah, this is going on YouTube.
That's gonna be my new ringtone.
All right. Download 2.5 videos of YouTube and do that. I don't even care. Oh, you're just gonna record it from your speaker, aren't you? My first thought is audio editing software.
Yeah, it's audio. I'm just gonna download the MP3 version of it and crop that part.
That works. Yeah, so same sort of thing. I got negative 30 times a negative 97. Okay. I tried the X, it didn't work for Ben. I went back.
I don't like the X either, although my immediate thing because of shop math is to put them both in parentheses.
We are definitely not doing that to this group.
No,
I love the X. I don't get why they switched it to the little dot.
because if you're using like an algebra, you'll have an X as a placeholder number.
Oh,
Yeah.
okay, that makes sense, I guess.
Yeah, let's say that if I was doing algebra, I would have X times 2X, and if I did that, it would look like that. And that would not be cool. That would not be cool. So that's why they went to a dot.
Do you have a special eraser for that?
Yeah, it's made of rubber.
Oh,
I don't recommend it
why?
because it actually can damage the,
Paper, gotcha.
yeah, you have to be stupid careful about it. Or you can get to the point where I can actually tilt this thing in the.
I mean, I
light.
just use this one gently.
Yeah, that's basically, yeah.
Same deal. Yeah,
Reusable notebooks, they are wonderful.
they are. I have two.
Reusable notebook?
Yep,
Yeah, they're great. You
this
can-
is erasable ink
The Rockable.
on
Same deal, like just
like a
bigger.
laminated plastic sheet.
And then you can use an app to scan it and then use water to wipe it off.
And that's the
Wipe it
plan
off?
later. Yeah, it just wipes off.
Yeah,
Oh,
after all this, I can show you if you want, because I'm gonna scan these and then wipe it right away.
oh. Just scan and save it onto your phone, just erase it.
I'm actually scanning it, saving it to a specific drive in my Google Drive that I set up specifically for this class.
Oh,
Because you can actually set up a thing called destinations in the app where you just X, I've set it up as the horseshoe. And so I just X on the horseshoe and it'll send it to it automatically.
It's gonna give it to you. All right,
These are awesome.
so I picked this particular problem because
The notebook sends it to your thing.
I'll show you after class.
Oh, okay.
it's all the app. You're literally, they call them smart notebooks, but it's literally, it's just,
The app is the smart part,
yeah, the app is the smart part. It's a sheet of paper.
Oh,
a sheet of reusable plastic paper,
Yeah,
oh.
that eventually you'll have to buy another one of.
eventually.
Yeah, I think I could squeeze about 3 or 4 classes out of them. So the reason I picked this problem is because what do you do when there's a 0 here?
Skip it and go to the next line, add a 0.
Well, that's the thing. We don't have to skip that line. Because up here, yeah, when we,
Well,
Wait.
0 times anything is 0, right?
well, yeah,
So what I'm saying is instead of doing the 0 times this, 0 times this, just because you're if you skip right to the tens, you could go down the next one, add a 0 because you're doing the tens and do the next one.
that's kind of where I'm going.
Okay,
But
so
you
I'm just
don't
like
need to
jumping
skip a
ahead.
random, you don't need to skip a line of nothing.
Okay,
The way I'm going is essentially when we came up here and I said, hey, by moving this 0 over and multiplying by this 1, you're multiplying by a 10, right?
Mhm.
That same concept applies right here. That 0 doesn't help us any. It's only gonna work if we multiply by 30, but I don't really want to think about it as multiplying by 30. So you kind of just, yeah, you start from essentially that row,
by adding a 0.
you just put the 0 there.
Yeah.
And then start from this guy.
So you're skipping the multiplying of the 0 and just
Yeah.
starting from the
0
10.
times 7 is 0, 0 times 9 is 0. Next line, 0 there, 3, blah, 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 blah. So we don't need that line of just 0 and nothing else.
You write out the zeros. So the 0 times 7 is 0, 0 times 9 is 0. So that would be that first line.
Yeah.
Which is kind of a waste of time, but
It's
it's
a waste of
there.
time. So I'm starting with over here. 3 times 7, 21. Carry that 2. 3 times 9 is 27 plus 2 is 29.
2,910 positive because it's two negatives, right?
Yes, because I have a negative times a negative, I end up with a positive. So this is an accurate number right there.
Because like what I did to hold, for note's sake, I put the 2 zeros in that line to remind myself, hey, we're just skipping the zeros.
Now, like I said earlier, estimation is useful. So if I looked at this and said, well, that was weird, did I get the right answer? Well, what's 97 close to? 100, right? 97 is close to 100,
Okay.
100 times 30,
3,000.
yeah, 3,000. 3,000, whatever, I can break.
And that's
vocabulary.
close. So yeah,
Yeah, so it's really close to 3,000.
No, I'm
so we'll
just-
teach you.
making the point because placeholders are a big thing for me sometimes in math because otherwise my brain won't wrap around it.
Fair.
So that's why I was like, okay, so I had put the 2 zeros in the row. And then I realized I didn't have to and kind of scratched them out.
Let's see here. I don't think I can go over long division in 9 minutes.
God, can we not?
I mean, I could, but you'd all hate me.
Please
I
don't.
came up with my own problem on my notebook.
That's rude of you.
See if I got the right answer to.
Let me awkwardly walk over here. Oh, that's great. All right. People get that all the time. Yeah, 152 times 93.
Yeah. I did that before you even started.
152
Okay,
times 93.
both
Let's do
positives?
152 times 93.
Is that?
Both positives?
Yeah.
Yeah.
Positives. You like that one, Teach?
It's beautiful.
Thank you.
It's beautiful and we're gonna work it together. It's exciting. We're all excited. We're all excited. What's the first thing I'm going to do, people?
Yeah.
Yeah, so we're gonna do 3 times this line. So we got 3 times 2, 6. 3 times 5, 15, so that one's gonna have to carry over. 3 times 1, 3 plus 1. Oops, so we got our 4 there. Gonna put a 0. That means we're gonna go over to this one. 9 times 2, 18. Gonna carry that one. Notice that what happens when you're carrying a bunch of things, if I had like 5 digits times 4 digits or something here, I would have tons of things
Right.
carrying. So if you end up with a problem like that, it might be good to switch colors.
What I learned is like to cross the one that you already used, like out, like just put like a little slant. through it.
That's an idea. Yeah, I like that. You could also like maybe make a line and the new ones are above the line, something like that. There's
Okay.
not really something that's a standard way of doing that. Just keep it straight, find a way. Fight your way through it, suffer. Suffer. 9 times 5, 45 plus the 1. 46, 4 gets carried. 9 times 1, 9, plus a 4, 13. That's big and ugly, isn't it?
Yeah. It's a nice looking color.
That's okay. We just add these rows together. 6 and 0, 6. 5 and 8, 13. 4 and 6 is 10, plus that 1 is 11. I don't know where to carry that. That's awkward. Whatever.
Oh,
It'll still add. That's in this digit.
It's a 0.
Yeah, it's like having a 0 and I'm adding it to one, adding a 1 to it. You know, there's nothing there I'm carrying over. Hey, this is a good example. And what do I do? Just put it there. It's kind of there. So we put a 4 there because we have that 3 and that weird floating 1 that's hanging out. And then we got nothing adding to the 1, so it just comes down.
1, 4, 1.
So we have 14,136. Which is the largest of our answers today. Beautiful. I like it. I like it. Everybody else like it? Everybody happy? We feeling good about this crap?
yeah.
Yeah,
I came up with a good problem, huh?
I'm proud of you.
Show everyone, hey, you can still put the 1 in that little spot, which I didn't even know I created.
You're like my son now. Wait, how old are you?
21.
You could be.
Yeah, my daughter's 21.
You're 40 something?
No, what?
No, if either of us had gotten pregnant in high school.
If I had gotten pregnant in high school, I'd be rich.
Well, my
Just
mom's
saying.
like 43.
Yeah, she seeing anybody?
Oh my
I said, no,
God.
not at the moment.
All right, we'll talk later. All right.
Number?
I think we're gonna call it good. I see everybody getting ready to run. So yeah, we will pick up next time with long division and we're gonna be happy about it. You're all free.
Banner.
Have a good night.
Thank you, man.
You are welcome.